Welcome and thanks for joining us. My guest today is Perri Adams, the Program Manager of the AI Cyber Challenge and Intelligent Generation of Tools for Security at DARPA. Perri, it's great to have you here.
Thank you so much for having me.
Absolutely, and it's been a busy summer for you with these two big programs really publicly launching. Let's get into them. I wanted to start out by talking about INGITS, the Intelligent Generation of Tools for Security program. What's the impetus behind that program?
So ingots, if you're familiar with like a gold ingot or a copper ingot, these are these blocks of metal. It's sort of a reference to mining. And today you have companies who really want to defend the software they create or the software they incorporate into their systems. And they run any number of automated tools on them, and they produce potential flaws, potential vulnerabilities that a hacker could leverage, but they also produce a lot of nonsense, a lot of information that's really not useful, false positives. So in the same way, when you're mining for things, you have a lot of dirt and other things you have to sift through to find those nuggets that you really care about. We have the same issue today. It's an issue of being able to run automated vulnerability identification tools at scale. So INGITS is really about solving this problem by developing automatic or semi-automatic methods of triaging vulnerabilities. So identifying, hey, what do we really care about? How severe is it to prioritize those for fixing or for remediation? You have software developers who aren't experts in computer security, but they're great at software development. And we want to give them the tools to reduce the amount of expertise they need and reduce the amount of manual time and labor required to identify what things they care about the most and prioritize those. So we're not wasting time on issues that aren't actually vulnerabilities, issues that a hacker couldn't leverage. And we want to make sure that the ones that hackers do care about, that hackers can use, we're fixing those first. And we understand how to fix them comprehensively.
Interesting. I mean, it sounds like a great idea. What's the work that you and the INGITS team are doing right now to really start developing some of these capabilities?
So the way that DARPA works is DARPA will develop a program, and a broad agency announcement will be released saying, hey everyone, we're running a research program. We'd love to hear your ideas. Please propose to it. Here's all of the technical information we're putting out to guide your proposals. And so right now I'm evaluating the proposals for the program, but I'm incredibly excited about when we do finally have proposals selected and people on contract, we can kick off the program and start developing these automated tools and techniques or semi-automatic tools and techniques to really help software developers secure their software.
Got it. And do you feel like this is a particularly urgent program, just given the speed at which cyber vulnerabilities are exploited, the rate at which new ones crop up every day, and now adversaries are looking at using AI to actually start attacking systems? Do you feel like there's a lot of urgency behind what is a research and development program?
Oh, absolutely. I think that this has always been urgent, but as more and more software is developed, as software becomes more complex, as we have more software engineers, but also as we have more automatic tools for vulnerability identification, the need for this continues to grow. In some ways, because we have improved our ability to automatically identify vulnerabilities, which is a good thing, the need for the ability to triage and have characterization of those vulnerabilities to remediate them comprehensively has also grown as well. So it's not the worst problem to solve, because in some ways it means that we have gotten better at the first step in some aspects, and now we need a program that focuses on the second step. However, the growth of software means that even our ability to identify vulnerabilities is still lacking to meet the scale and the severity of the problem today.
Sure, that makes a lot of sense. I mean, and you mentioned the terms triage and characterization. This is essentially, you can identify the vulnerabilities, but now you need to understand, all right, this one is the most important, this could be exploited today versus this one, it doesn't really matter.
Yeah, I mean, anyone can understand this. You have a number of tasks in your job that you have to handle, but some of them are going to be more important than the others, right? You know, briefing the boss is going to be much more important than a small administrative task without a deadline. And you have an understanding of how to triage those tasks, and you're doing it on the fly as you're thinking about what you have to get done, or you might actually have a to-do list where you do that manually. That same thing software developers have to do with all of the flaws that they receive, all of the bugs that they find in their software, vulnerabilities. And they also have to create new features. They have a number of other things on their plate. So we need to give them a way to say, hey, these are the ones you really care about. These are the ones a hacker could actually use. That's part of the characterization as well. Characterizing the aspects of the vulnerability, what the actual root cause is, so that the software developer doesn't have to spend hours investigating the vulnerability, but can say, hey, here's the actual root of the issue. Here's how I can fix it. Because today you might have fixes for vulnerabilities that don't actually fix the issue. And what ends up happening is that fix can sometimes tell a hacker, hey, there's a problem here. And then the hacker will go look at it and say, oh, the fix isn't complete, and they'll circumvent it. So we want to make sure not just that we're prioritizing severe issues, but we're fixing them comprehensively.
Interesting. And so what's the state of, you know, automation to actually be able to go out and do this today? I mean, I think you mentioned that vulnerability scanning can largely be automated, picking these things out, but...
I'd say that vulnerability scanning is something that we have made progress in automating, but there's still significant issues with automating that, and I'm actually focusing on that in a separate program that I think we'll talk about a little later. But vulnerability scanning today, one of the issues is that it produces high rates of false positives. Like I said, there's a lot of other information that gets released as well. However, what we're focusing on is automatic tools that don't focus on identification, but when there is some form of identification, characterizing and assessing the severity of it. So for instance, one way we identify potential vulnerabilities in code, issues in code, is looking for program crashes. When the program, you've seen this, if your program suddenly quits without you understanding why, without you closing it, that's a crash. And that likely indicates that there's a bug. That might be a vulnerability, or it might be a benign flaw. And so that crash, however, is not going to be the same thing as the root cause of the vulnerability. The crash is a downstream effect. So one of the things we're going to focus on is the development of tools that trace backwards from that downstream effect, from that crash, to the root cause, and tell the developer, hey, I know this crash happened down the line, but here's where the issue actually occurred, and here's where you need to fix it, and actually here's what the issue is. Maybe we counted a little bit too far, and we need to fix the numbers, right? It'll tell you that, so the developer doesn't have to spend a lot of time investigating.
Got it. And this Ingots program is specifically geared towards software developers, the folks who are shipping software to customers, right? It's not necessarily focused on like end-use customers applying this to their environments.
Ingots is focused on both software developers as well as folks looking at third-party software that they're incorporating into either their networks or their products themselves. So obviously you can use this on your own software. You can also use it to look at the software that you're putting in your networks. You want to make sure that a hacker can't get into. And companies already do those kinds of evaluations, and we're just giving them more tools to do that.
Interesting. I ask about the software developer piece because there's been a lot of focus from the government on, you know, secure software development, ensuring software makers are doing their due diligence. So it seems like if this is successful, this is something that a lot of software companies would want to adopt someday.
Absolutely, and that has been part of what's motivated this. I'm sure this is the Federal News Network, right? I'm sure people are familiar if they've ever done, if they've ever been part of the acquisitions process for software, but there's requirements in some cases to run these automatic vulnerability identification tools. But again, these do produce high rates of false positives, and they're difficult for the average software developer to reason about the outputs of. So this is a program that would pair with those tools and or pair with better versions of the tools, and would help the developer be able to actually fix those vulnerabilities, which is what the requirement to run the vulnerability identification tools is about in the first place.
Sure, got it. So I know you're evaluating proposals now. Has there been a lot of interest in participating in this program? Can you generally characterize that?
Yeah, well, obviously we're in proposal selection, so I can't talk about any of the specifics of that, but what I can say is just in general, I've been incredibly excited about the response to Proposers Day and to all of the questions we got in about the program before that. I think that the community is incredibly excited, the research community is incredibly excited to participate in a program like this.
And I know DARPA does programs in phases. This is a two-phase program, correct? How will that work?
So the first phase is really about proving viability of a wide range of approaches. So I won't call it throwing stuff at the wall and seeing what sticks, but part of that is giving the researchers that will eventually come on the program the opportunity to try a lot of things, see what works, what doesn't on a couple, on some like smaller example problems. The second phase is about maturation. Let's identify what worked in that exploratory phase and what didn't, and let's mature the technology that has shown a lot of viability. That way we're not going to spend a 3-year program working on things that didn't show a lot of promise. We can focus the effort on the things that are likely to succeed.
3-year program, so hopefully 3 years from now we'll have you back here and it'll be
Absolutely,
success.
I'd love to.
Yeah. All right, well, I know there's another big program that DARPA just launched this summer with a lot of fanfare, the AI Cyber Challenge. This is kind of modeled after DARPA's previous grand challenges. You know, how is that distinct from the INGOTS program? I know some similarities, but how is that different? What are you looking to do with the Cyber Challenge here? That's
actually very distinct from the INGOTS program. Obviously, both of them focus on making sure our software is more secure, but the AI Cyber Challenge is a challenge about being able to identify and fix software vulnerabilities at scale. So I was incredibly excited to announce the AI Cyber Challenge at the Black Hat Conference in Las Vegas, and then give a subsequent announcement panel at DEF CON, also at Las Vegas. These are two of the world's largest hacking conferences, and that provided me with an excellent platform to put out a call and say, DARPA really wants us to be able to secure software at scale. And I was incredibly excited that the White House also put out a press release really highlighting how important this is to the administration and to the White House's focus on secure software development and securing software, but specifically the software running on our critical infrastructure, which is what AICC will focus on.
Yeah, and what was the reception at these big hacker conferences? Perfect place to really roll this out. What's been the feedback so far generally?
It was a fantastic reception. I have been gratified by just how many people are excited to participate and who see this as an opportunity to put their skills, whether it's in AI or computer security, towards a really critical national security issue. I'm also really excited to have a number of collaborators on the program, on the challenge, who see this as a key need for improving the security of the software on which society relies. So this is really the first of its kind collaboration between top tier AI companies. So I have Google, Microsoft, Anthropic, and OpenAI, and I've brought them together on this effort, and they're going to make some of their cutting edge technology available to participants to build on top of, to build software security tools on top of, and they're also going to advise us and help us make something that really drives the development of AI-driven systems towards solving real world challenges. And to that end, I also have the Open Source Security Foundation, which is a project of the Linux Foundation, working with me as well. Because open source software makes up about 80% of the software that we see in many critical infrastructure sectors, but it also makes up the vast majority of software generally. It's the software that you and I rely on, our parents rely on for water, for electricity, for telecommunications, for calling us. And so by focusing, by partnering with the open source community and by using those projects as exemplars, we can model challenges on real world problems. But we can also make sure that we are hitting as broad a swath of software as possible with our tools and making our tools applicable to it.
Got it. That's very exciting, and you're hitting on a lot of different areas. The open source software security, obviously so important. Using AI to advance cybersecurity, obviously the whole focus of this challenge. Applying these major AI companies, I guess, their models toward this problem. That's pretty significant. How did you come to those agreements? Was it easy? How did you get them involved here?
So I'd say that these companies, as software companies, see the need for better software security tools. They deeply, innately understand the criticality of software security and how difficult it is to do this at scale, especially as we develop more and more software, as we have legacy software running on these critical infrastructure systems. So they see all of these problems, and they're also committed towards using the novel AI technology they're developing to help solve some of these key societal challenges like cybersecurity. So frankly, when I approached them and said, hey, I want to put together this challenge, an opportunity for computer security experts to use AI to significantly improve software security, to really make leaps and bounds in the space, they were very enthusiastic and just said, how can I help?
Got it. Interesting. And so how will this program work? I think you're soliciting some proposals right now. How's it going to work going forward?
So unlike a traditional DARPA program, this is a challenge. And so I encourage all of your viewers who are interested to visit aicyberchallenge.com, because that has a wealth of detail on how to participate, on the structure of the competition, etc. But I'll walk you through a little of it right now. So the challenge will have three competitions. So and there will be 2 tracks for participating in the first sort of phase of the challenge. So we have an open track that's really open to anyone who wants to participate, subject to some eligibility requirements, which are on the website. In addition to that, because we want to incentivize entrepreneurial innovation, and we want to make it possible for small businesses to participate, DARPA is making available up to $1 million for up to 7 small businesses to participate in this effort. And we've actually just extended the deadline for submissions to October 3rd. We're using Small Business Innovation Research awards for this, and so that SBIR award is open for solicitation through October 3rd, and that will fund small businesses to participate. But both tracks, the open track and that funded track, will participate in a qualifying competition in late spring of 2024. So we're going to kick off in February, and then we're going to have some pre-qualification events, and then we'll do a qualification event. And the top 20 teams will advance to the semifinal competition, which will be in Las Vegas at DEF CON in 2024. The top 5 teams there will each win $2 million and will advance to the finals in Las Vegas at DEF CON 2025. And they will have those $2 million each to spend a year maturing their systems and building them out to compete in this final competition, where the top prize will be $4 million, the second place prize will be $3 million, and the third place will be $1.5 million.
Yeah, it's fascinating. We'll be able to see these developments happen year over year, at DEF CON going forward. And I think one thing that was mentioned is you're asking some of the competitors to potentially make their prototypes or products open source going forward as well, so kind of everyone can take advantage of them. Is that right?
Absolutely,
Yeah.
that's an incredibly important part of this effort. Is to get the prize money, you're going to be open sourcing the tools you develop, because we want to make this available to everyone to use on either the software they develop or the software they have to put in their systems. And so we're going to be developing AI-driven tools built on top of some of the latest and greatest in AI technology. Some of these models we're seeing come out of these companies. We are going to develop systems that can automatically find and create fixes for vulnerabilities in software, vulnerabilities that a hacker could use to get in. We're going to design these systems to fit within the software development process. That's another aspect of our partnership with the open source, with some of these open source groups, is to develop things that can fit within the software development process, which the open source community has so much expertise in, and can suggest fixes for vulnerabilities in the same way that the open source community has developed over decades and decades. So they have a system where, hey, anyone can suggest a change to code, but that's going to be reviewed by the maintainer of that code repository. And that's an incredibly important sanity check. And that helps keep the balance between, this is open source software, anyone can suggest a change to it, but we're going to have the experts on that piece of software make sure that that change is correct. In the same way, our AI-driven systems are going to suggest changes to code. They're called commits, and they'll go through the exact same commit process that open source software has today. But of course, the tools we're developing are for any kind of software. Open source software is just software, and internally at companies, they have the same or similar development processes.
Sure, that seems pretty key, is making sure it can fit within these processes, or else it's not going to be used as well as it could, at least. And so what do you see as some of the big challenges with this challenge? I mean, and we know it takes some time to train these large language models on specific problem sets. I mean, what else do you think is going to be kind of confronting these competitors as we go through the process?
Absolutely. So again, we have those two stages, and that second year is probably when we're going to see more complex, complicated approaches that involve significant training time, if that were to be an avenue that competitors pursued. And in that initial phase, it's going to be, how do we leverage the AI technology that we have access to today? How do we tune it, or otherwise leverage it for securing software, with an eye towards what they would do if they were one of the 5 teams that won that $2 million. And so I think that we're seeing a lot of promise in, let's take generative AI. So what a lot of people have been talking about, these large language models, right? That's a form of generative AI. And these models like ChatGPT or Anthropic's Claude, they have the ability to reason over very large data sets of text, and then produce text. And we've actually seen that able to be applied to code, not just with Microsoft's Copilot, GitHub's Copilot, which automatically writes code for you, but in other just trivial applications of ChatGPT to the code generation problem. We've also seen the ability to apply some of these LLMs to identifying vulnerabilities within code. And in some cases, it's been successful. But there's been there's still significant progress needed. So sure, it can find some vulnerabilities, but it also has a lot of false positives. It gets things wrong quite a bit. I mean, anyone who's interacted with LLMs has seen that they have significant potential, but they do have limitations. And we're going to marry that with traditional computer security approaches. It's a domain of computer science called program analysis. So code understanding how code is working so you can predict behavior, you might identify vulnerable behavior. And these are more expert-driven systems, logical reasoning systems. We're going to be combining the two. And where that combination happens, how these two, how AI and traditional computer security approaches fit together is going to be one of the core challenges facing competitors.
Got it. Is there anything else that you think is particularly important to mention on the cyber challenge specifically as this really sets off?
Just that, again, that cyber deadline for proposals is now October 3rd, and OpenTrack will open for participation in November. We kick off in February, and I would love to see as much participation as possible from the research community.
Got it. Very exciting. Well, I mean, and taking a step back here, obviously these are two programs that we've talked about focused on applying AI to cybersecurity. I mean, you've touched on this throughout our conversation, but more generally, I guess I'm wondering, you know, why is it so important to be thinking about using AI to the future of these cybersecurity tools, of the future of cybersecurity going forward? How has that developed in your mind?
So AI is one approach that offers an enormous amount of potential, and to date we haven't seen it harnessed as much for different problems within software security. Part of that was because in the past AI has not been that mature, and it has now had the opportunity to mature and really exponentially leap forward in recent years. However, it's also the case that the problems within computer security are often incredibly complex. To identify a vulnerability within code, that requires an enormous amount of expertise. These essentially reduce to complex mathematical problems. And to solve them automatically, you have to create complex algorithmic structures that you can reason over. One thing that you run into in this domain of computer science is what we call the state explosion problem. There's just so many different states that your computer program could possibly be in. That number becomes just so large, no computer can actually handle it. What AI is really good at, though, is statistical reasoning, like finding patterns in a wealth of unintelligible data and picking out those patterns that maybe even a human wouldn't be able to find. And so our challenge here, and one of the barriers towards the application of AI to these software security problems is just representing the software security problems in a way that AI can reason over. So you have to be able to encode some of these mathematical properties, some of these logical aspects in a way that we can then apply the AI approaches we have today. And that's really what a lot of my programs, a lot of my efforts are focused on.
Got it. And I mean, we haven't talked about it a ton, but what about the use of AI by malicious actors? You know, I mean, I guess the only difference between a white hat hacker and a malicious hacker is how they use their knowledge going forward. But what about AI? You know, how is that potentially being used by malicious actors? How does that factor into DARPA's programs here?
So a lot of my programs are about securing software, and that's securing software against a hacker using any technique. So if AI is able to aid hackers in one way or another, by investing in software security, we are investing in a future where software is better defended against any kind of attack.
Interesting. And you know, I'm wondering, you previously served as a technical advisor at DARPA, and I saw in your bio you were helping to foster some interagency relationships to transition technology. I think a lot of our audience is always interested in this concept of the valley of death, you know, just getting from research and development into operations. Whether in this context or otherwise, what do you think is particularly important to solving that issue?
So DARPA is an agency that funds cutting-edge research, but DARPA doesn't ever want to own anything long-term. Our goal is to spur innovation, spur research, and then make sure that research ends up in the right stakeholder hands, whether that's other government agencies, other government partners, industry, the nonprofit community, NGOs, whomever. And so one thing that I worked on is really about developing those relationships. As many people within government know, navigating bureaucracies is all about the relationships and the trust that you can build. So one thing, you point to the Valley of Death, that's really, researchers will spend 3 to 4 years developing something, and then you'll go to a partner that might be able to leverage this new cutting edge technology, and they say, well, this is great, but it has all of these issues that had we been able to tell you that 3 years ago, it wouldn't have had. And also, we don't have a funding line for it, and we haven't budgeted for that, and et cetera, et cetera. We don't have a program office stood up, what have you. And so by communicating early with transition partners, bringing them into the process and saying, hey, what are your problems? Understanding what they are and using that to guide but not constrain the research. You want to explore all possible things, but with an eye towards if you have a choice and it could be aided by the needs of another agency that might end up using it. It's very helpful to have that context. Something that DARPA is currently exploring right now is how we actually leap over the Valley of Death when it comes to our cyber programs. And so DARPA has actually partnered with Cybercom for an effort called Constellation. And that's a joint effort to be able to take the software that DARPA produces that might be applicable towards cyber defense, the cyber defense that Cybercom is charged with, and bridging that Valley of Death.
Really fascinating. I mean, Cybercom seems like the perfect organization, of course, to be working with on the cyber tools you're developing. Constellation, just generally, when did that kick off, and where is that going?
So I don't want to go into too much of the specifics today, but that's an effort that I believe was announced sometime last year. However, with regard to the AI Cyber Challenge and ingots, my transition partners are anyone throughout government and private industry, commercial industry, developing software. So we're hoping to actually open source most of the tools that we develop on these efforts and give that back to the community. So government stakeholders, whether they're in the DoD or other agencies, as well as the open source community, who really is our primary transition partner on that effort, and the commercial community that leverages open source software or has similar development processes.
Got it. I mean, and so as someone with a technical background like yours, I'm just curious, there's a lot of conversation around getting more STEM folks involved in government, broadening out the pool of available STEM talent. How did you get involved in government service, and what makes you stick around?
I'm incredibly passionate about government service, about national security work. So I actually went into computer security when I was a computer science major in college, and I cared deeply about national security. I was really passionate about computer science. I like the math side of it, but I didn't necessarily know if I just wanted to do software development. And there was a computer security club at my school that played these hacking competitions. And I saw the intersection of national security with cybersecurity, and I thought, well, this is a great opportunity. And so I decided to focus on cybersecurity in college, and that really led me to where I was today. But I always knew coming out of college that I wanted to work in government service, because I think the government has an incentive to make our software more secure. And that incentive has driven agencies like DARPA to really invest and be on the forefront in many aspects of software security.
Interesting. You're the second person I've talked to within the last month who's talked about the importance of hacking competitions and just competing on that front. It seems like that's a way a lot of folks get involved in the security side of the field going forward.
And I can actually say on that point, my experience, my deep experience in the what's called the capture the flag community. I'll give a little background on that, was what really drove me to create a challenge, because I think challenges, competitions are really great at driving, not just driving innovation, but bringing together people from different research spaces and having them really combine their expertise to create something really new and really powerful. So when I was in college, what I got into is called Capture the Flag, which is we want to create hacking competition in a safe environment. So we're not going to be hacking other people's computers. We're going to be hacking computers set up for the challenge. And you get on there and you hack into it. And you don't do anything malicious. You just capture a flag, which is a string of text that you can't necessarily guess, right? And so I got very involved in this. I was lucky to play with some really excellent people. And I used to compete in DEF CON's Capture the Flag, which is seen as the really global Olympics of hacking. Maybe 1,000 teams participate in qualifiers in May, and 10 to 20 every year fly out from across the world to Las Vegas to participate in the finals. And today, I'm one of the organizers for that competition. The organizers switch over every 4 years. But playing in these competitions is what taught me so much about cybersecurity and taught me so many different aspects. So challenges will be about reverse engineering, or vulnerability discovery, or application web security, web application security, or cryptography. And you have people with specific expertises in those areas. You usually will specialize in one or two things. And so when you're playing, though, you have challenges that span over those different categories. And so folks will often bring together and say, hey, I have expertise in one of these areas, or hey, I have expertise with this specific class of software applications, or class of network devices that we're seeing here. And so you really you work with a ton of different people and you combine expertise on different kinds of challenges for these hacking competitions. And that really taught me the power of competition at driving innovation at the nexus of different research spaces. And so when it came to the AI Cyber Challenge, I saw these two different areas, AI and computer security, that hadn't really been combined as much as we'd like when it comes to software security. And I said, well, let's use a challenge to drive that innovation forward.
Wow. Yeah, that's a fascinating way to approach it. And I mean, part of what I'm curious about is also bridging the gap between the government and the security community. It seems like that's increasingly, those two groups have increasingly gotten closer over the years. I mean, you now have the Secretary of Homeland Security giving one of the keynotes at Black Hat, I think. What's your views on how this has developed as someone who's been in the security community? You have the foot in the government camp. I would assume you probably consider yourself feet in both camps now. What's your view on that issue?
I think that having government folks involved in these spaces, hearing from hackers, or like myself, having one foot in both camps, is incredibly important to bringing this perspective, bringing these voices into government spaces. But also having the community understand how the government works, understand how the government thinks about cybersecurity, and it helps the two communities work together to drive towards an issue, to help solve an issue that both camps really care about deeply.
All right, any just closing thoughts on the issues we've talked about today, using AI for cybersecurity, such a big topic. You're on the forefront of that. Any closing thoughts for our audience?
All I'll say is that I think the gains we've seen in AI have enormous potential when used well. And I'm a little biased. I care deeply about cybersecurity. I care deeply about software security. And I really want to see AI's potential applied there, and that's what I'm hoping to do with the AI Cyber Challenge. That's what I'm hoping to do with Ingots, and I'm incredibly excited for what we'll see the research community produce.
All right, Perri, thank you so much for your time.
Thank you so much.
All right, again, I'd like to thank today's guest, Perri Adams, the Program Manager of the AI Cyber Challenge and the Intelligent Generation of Tools for Security program at DARPA. I'm your moderator, Justin Doubleday, and you're watching Federal News Network. Now let me send you back to the studio for more on the Cyber Leaders Exchange.